We know an electric dipole is two charges of equal magnitude separated by a short distance. So we have a plus q charge and a minus q charge separated by a short distance. Let us take the distance as 2a. So now we are considering a point on the equatorial line, say P, and we are going to find the electric field due to the dipole at point P. Let the distance from the center of the dipole to P be r. We know that the electric field follows the superposition principle. So the total electric field at P, E will be equal to electric field due to plus Q charge plus electric field due to minus Q charge. Okay, so first we need to calculate electric field due to plus Q charge. Then we need to add electric field due to minus Q charge. So let us calculate electric field due to plus Q charge. So we know electric field will be along the direction of straight line joining the charge and the point. So the distance will be this. We know that from the charge to the center of the dipole is A, and the distance between center of the dipole to the point is R. The distance between plus Q and P will be root of R square plus A square. So we can write E plus Q as 1 by 4 pi epsilon 0 Q divided by root of R square plus A square, the whole square. So since we are taking the root and the square, the root will cancel out and we will get R square plus A square. Since it is a vector quantity, we know the direction of electric field due to plus Q will be in this direction. So that is, if this angle is theta, we can take this angle also as theta, and the magnitude of electric field in this direction will be E plus Q cos theta. So you can write this quantity is E plus Q, and to indicate the direction we need to multiply cos theta here. Now let's calculate electric field due to minus Q. It will be 1 by 4 pi epsilon 0 times Q divided by the distance square. The distance between minus Q and P is this, and we know the distance between center of the dipole to the minus Q is A, and the distance from center of the dipole to point P is R. So definitely this side will be root of R square plus A square, same as in the previous case. So we can write the distance as R square plus A square. Again, when we look at the direction, we know the direction will be minus Q to Q. So that will be again in this direction. E minus Q cos theta. So we need to multiply with E cos theta. E plus sin theta is in this direction, and E minus sin theta will be in opposite direction. Sin theta. So they will cancel out. That's why here we consider only cos theta. So now we know the total electric field will be the sum of electric field due to each charges. So now let us write the equation for total electric field as E is equal to 1 by 4 pi epsilon 0 Q divided by R square plus A square cos theta plus 1 by 4 pi epsilon 0 Q divided by R square plus A square cos theta. Definitely the electric field due to both minus Q and plus Q are same. So it will become 2 times Q divided by 4 pi epsilon 0 into 1 by R square plus A square cos theta. So come back to the diagram. We can understand that the cos theta, if this is angle theta, cos theta will be adjacent side divided by hypotenuse. Adjacent side is A and the hypotenuse is root of R square plus A square. So the value of cos theta will be equal to adjacent side divided by hypotenuse, which is root of r square plus a square. So if you substitute the value of cos theta in our equation, the total electric field E will become 2qa divided by 4 pi epsilon 0 into 1 by r square plus a square into 1 by root of r square plus a square. So let's resolve and rearrange. We know the value of 1 by 4 pi epsilon 0 very clearly. So let us take that outside. 2qa, which is dipole moment P. 2qa. So instead of 2qa, let us substitute the value P. P is dipole moment divided by r square plus a square raised to 1, and root of r square plus a square you can write as r square plus a square raised to 1 by 2. So 1 plus 1 by 2 will be 3 by 2. So it will be r square plus a square raised to 3 by 2. So this is the expression for electric field due to dipole at an equatorial line. So one more thing we have to do is that we know the distance of separation between the charges are very short. So if you take the value of a square, it will be very much less than a. Okay, so is r is very much greater than or larger than a. So let us neglect the value a square. So now after neglecting the value of a square, we can write the equation as 1 by 4 pi epsilon 0 P divided by r cube, which is the expression for electric field due to dipole at an equatorial line.